Hello everyone. Hope you all are doing great and welcome to this stream. So, in today's stream, the plan is to pretty much work on the TinyRaster, which is a software rasterizer that I'm building. I hope my audio is okay. I'll just check that. The TinyRaster, which is a software rasterizer that I'm building. I hope my audio is okay. I'll just check that. The TinyRaster, which is a software rasterizer that I'm building. Okay, I'll just check that. The TinyRaster, which is a software rasterizer that I'm building. Okay, hope you all are doing great and welcome to this stream. Hope you all are doing great and welcome to this stream. So in today's stream, the plan is to pretty much work on the I think today's stream, the plan is to pretty much work on the maybe I'll just try to reduce the microphone gain. Maybe I'll just try to reduce the microphone gain. Is it better now? Is it better now? Is it better now? I think this should work fine. So guys, as we are awaiting the new year, I thought like I should give it a head start by trying to implement at least a new feature in TinyRaster. So if you guys don't know, this is a software rasterizer that I'm building from scratch using C++. So this is my repository. I'll put a link down in the description which you guys can check out. And yeah, so like I'll show. So this is a bit of the implementation. I have written a header only math library which does not have much at the moment, but it only has um, the vector 2 vector 3 class implementations and all the basic vector operations that you can imagine implemented inside of it. And by the way, we are listening to the Smiths while coding. Like the Smiths have been a go-to band to listen to. It's like really fun to listen to those songs. Let me know if you guys want to hear to some other beats. And then I have a simple abstraction for the vertex data. It's nothing much. So it is a software rasterizer. So we don't have those fancy vertex shaders and fragment shaders that we get to use in our graphics APIs such as OpenGL and Vulkan or something like that. So for this software rasterizer, I just created a struct which contains a vec3 for position and a vec3 for color. I do not have the normal or texture coordinates implementation because obviously I have not implemented that yet, but I have kept room for it, so I've just commented it out. And then there is the meat of this TinyRaster thing. This is the frame buffer. So the frame buffer is nothing but a collection of pixels, a 2D grid of pixels where you can just lay down your pixels basically. So right now the setup is pretty simple. Like I just have this empty class invalid in each of the class members so that I wrap my code inside of this try and catch block, and I try to check if this is invalid. I return invalid when obviously I get an error or something like that while using my frame buffer library. And then I have this static integer inside of this class which is actually defined in this frame buffer CPP file. It's a clean CPP file, so it's mostly header only. And yeah, so this is nothing but like right now the setup is that I render the output to a ppm file. So a ppm file is just a separate format. As if I want to if you all guys want to see, like, this was the output generated by the ppm file, which I later converted to a png by using ffmpeg. And this was nothing but like generating random colored and random position lines at random locations. So this was the first milestone of TinyRaster. And then I implemented rasterization of triangles. So this was the output from that. And after that I did implement interpolation, and this was the result of this. As you can see, like, each vertex has a different shade of color, and it is interpolated across the whole triangle geometry. So yeah, it's basically like I interpolate first along each edge, and then I interpolate across like this, if you get the point, right? And this is the classic triangle that you all render when you are trying to learn any graphics API. So this is what I also made using that interpolation thing that I implemented. So that has been the thing right now. And I did try implementing perspective projection and stuff, but the results were not so great. Like, you can see, um, I tried to render the front and the back face of a cube, but as you can see here, it is kind of rendered side, like, not one behind the other, but it is kind of laid on the same plane. So I need to fix that issue. Hopefully I'll fix that today. And yeah, like, I was in the middle of implementing vector 4 and some matrix multiplication operations and stuff, so that all these transformations become easier for implementing, and the perspective projection would hopefully be working right. And I have this conditional compilation thing, just for debugging stuff, like, just getting the information, like what I am doing and all, like that. This is just basic things, operator overloading and all. Then I have this method which is called the clear frame buffer. It does nothing but takes a single color, and it just blends it, or completely clears it with a single color shade of color. And I have overloaded methods for this function, like taking in RGB values or taking a predefined color. So this color is a separate class. I have an enum for the separate predefined colors, and this method is nothing but it is just checking for an enum, and it is just returning the name in string format. And this is the meat of this color class. Basically, we have these individual color channels, RGB, and yeah, it's just basically holding RGB, and there are different operations that you can do with it, indexing and stuff. And this is the set color method, which takes in an enum for the color, a predefined color, and it returns the RGB values for that. And yeah, it's a pretty simple implementation for that. And yeah, then later we have a method called put pixel. I have various overloaded methods for this, incorporating a vector to a vertex or anything like that. So like whatever the user wants to use as per their convenience. So this does nothing but indexes into a frame buffer and puts the color at the specified location. And after that I have a method for put line, so the put line method takes in 2 points and a color for the line, and it just, you know, draws the line using basic interpolation, just the basic math. It is not really optimized, I would say, because you know there are so many things going on here, and the optimized way would be to use Bressenham's algorithm for drawing a line, which I am going to implement, but that's not the priority for now. Like, I am trying to, you know, get things running in 3D first before I do all the optimizations and stuff. And like, I am just allocating memory inside of this, which is also an overhead, like using vectors and stuff for temporary storage. And I don't think there should be anything like cache level optimization, because like I am accessing all these vectors in a sequence, so like that should not be a problem. But the main overhead is like creation of this vector and stuff like at the start, and after like getting those points after interpolation, like I go from the given x, the smaller one, to the larger value of x, and then I interpolate the values of y, which is given by ys, and for each x I just you know, put the pixel at the specified coordinate of the specified color. So that's it, like for the line, it's as simple as that. Then moving on to the next method, I have the put wireframe triangle method. I don't know like why I, you know, prefix every method with put, but you know I was like fascinated by the VGA programming stuff from the MS-DOS era, and it has a few methods, I believe, if I remember right, like prefixed with put. So that's what inspired me for using the put prefix up before, you know, each and every method which I used to rasterize or render something. And this put wireframe method does nothing but takes three points, and it just, you know, uh, runs the put line method for every other point, every other 2 points, and thus forming a wireframe triangle. And then we have the put fill triangle method. So this is just like the, you know, put line method, but it is actually, you know, going across like and filling up each scan line and filling up the entire triangle area. That's it. And later on we have this blit frame buffer method. Right now it just stores this to a ppm file in binary format, and yeah, it's just copying those pixels. Blitting is nothing but copying those pixels from this frame buffer to the ppm file. So we just blit these frame buffer content to the other frame buffer, which is our ppm file basically, and we just have the width, height, and the array allocated on the heap for the pixels. That's it. So like, if I have to show you all the running of this thing, I'll just uncomment this. Okay, so this just creates, you know, different shaded triangles at random locations. So I'll cd into build. Error line 239 mat.h. Oh yeah, like I was in the middle of implementing the vec4 thing, and yeah, let me just comment it and show you all guys how it runs first. just split these frame buffer content to the other frame buffer, which is our ppm file. I was just checking the sound quality right there. It's all right. Yeah, I think it should compile now. And one thing that I can do is I'll make it as like I'll enable the compiler flag debug, which I set earlier, which will just print the log lines. It slows down the application quite a bit, but you'll be able to see what is exactly happening. It puts pixel at these coordinates exactly, like we have generated these at random. And now if we see this frame 0 dot ppm, strange. I wonder why this did not work. Let's change the background to white. And this thing, the area computation, I am just doing this to ensure that the triangle is not like of zero area, like it should be like the three vertices are visible at least. Otherwise it would appear like a line, even if the third point is quite closer to the line that the other two points form. And okay, yeah, this should work, I think. I wonder what is happening to this. Let's delete it and run it once again. Okay, it actually did not run properly. There is some kind of error. Terminate called after throwing an instance of std bad alloc. Okay, let's try to debug this. Oh, I got what's the problem right here, because what we are doing is we are just putting this thing into the frame buffer, but we are not actually updating it to our ppm file. So I'll do just that. I'll just check what is. template frame buffer. Yeah. Now it should work all right. Yep. As you can see, this worked and just generated some random triangles with random colors for each vertex. Cool. So now I'll just get rid of this. We don't need this. And what I'll do is I'll go on to implementing this thing. Yeah, I need to change this thing. Change this to vec4. Like the thing is that most of the vec4 functionality is similar to vec3, so I just copied my vec3 class implementation and I'm just making some changes to make this valid for vec4. I'll maybe play something lofi beats or something. I need to add more combinations right here. For the getters, XW. We have the all the swizzles possible for vec 2, and now let's do for vec 3, xyz. X Z Y. I did play Lofi, but got these out of the way, and now I'll have to implement with W as well, but I don't think so I require W as such. I think these swizzles are more than enough, I think, for now. And let's add one for accessing W separately. We will add more swizzles if we need them. Done with these methods, getters and setters. Now let's edit these copy constructors and copy assignment thingies. This is the default constructor without any arguments. We have vec 4 working, and I think I'll add one more constructor which will take a vec 3. Let's do a constant reference to vec 3 and w separately. That's it. Guys, if you are new to the stream and already liking what I am doing right here, please consider liking and subscribing to my channel. That really helps and shows some support. Also, I recently wrote a blog on my website. You can check it out in the description of this live stream. It's on viewing in 3D graphics. So like it's how the 3D coordinates that you specify to your computer are mapped to your screen, which is 2D. So like the method of projecting those 3D coordinates onto your 2D screen, it's what is called as viewing in computer graphics. So it's explained in much detail in that blog post. You can just check it out. Just give it a read, it won't take you long. And I have uploaded part 1 for that, and I'm soon going to upload the other part as well, so stay tuned for that. I think vec 4 is done. Now I'll move on to implementing mat 4 for 4x4 matrix. This is our 4x4 matrix, and let's create some basic methods for this. A default constructor, what this can do is just initialize everything to 0 maybe. Yeah, coding weekends like GLM would be a much better and optimized thing to use, but I wanted to make everything from scratch. It would be great for learning experience as well, so that's why I was trying to implement everything from scratch. It won't be as optimized as GLM is, but it's good if you implement everything by yourself at least once, so that you get used to stuff and know how things work under the hood. So I think I'll just keep this as is, and maybe I'll just make this public as well, because I don't want to write getters for each and everything. I can maybe use operator overloading for this. I can write a static method maybe. So this static method will just return an identity matrix which is of size 4 by 4, and I can just put in different stuff directly by indexing this. I don't want to increase the complexity of this, and what I can do is add a getter of type vec4 maybe, get row, and I'll add it index. I'll return a vec4, and I'll do coding weekend says static for a void identity is a bad idea. Why is that? Like, I'm not aware of it. Like, could you tell why is it bad? Is it something related to the performance? Yeah, I think I can just make it inline method outside of the class as well. Coding weekends is trying to suggest something. Could you like tell what is wrong with static void? Like, how can this be bad? I'll just continue with this implementation while you type. I'll just add another check maybe. Now that is done, and I think we can move on to adding the projection matrices and something like that. I'll just open up Krita for for 4 by 4 matrix. I should implement multiplication with a vec4. I'll treat a vec4 as a column vector, which is 4 times 1, which will return a column vector as well, vec4. So I have this r0, 1 and 3. I need to multiply the row of this with this thing. I'll add a getter as well. Yeah, I have a get row and get column method which returns a vec4. Now what I need to do is I need to let me check if I added an operator overloading for that. Yeah, this thing. I need to take dot product of the row and columns. Yeah, and then I'll just replace it with that thing. I'll add an operator overloading for that thing. Which will return a vec4. What this will do is it will return a vec4 where we do a dot product basically. How do I write this? Let me check how did I. Oh shit. I now get coding weekends point. I totally missed this thing because I am trying to return a value from this function and I named it void, which is a bad thing to do. It should be static mat4. Yep. Now I get your point, buddy. I just totally missed it. It's quite quite easy to make silly errors in this. Yeah, I think apart from that, yep, got it. And now what we can do is, like, do I have a method to print out? Okay, never mind. I'll just comment out all these things and let's try out our vec4 and matrix multiplication methods. What I'll do is I'll just, do I have, yeah, fine. What I'll do is I'll create a mat4 and I'll name it I. I'll do I do need to implement a simple constructor. I'll just keep it default. Or maybe let's keep it an identity matrix. This should work, and after that let's add well, I cannot do much in the initializer list. We don't require any move constructor because we are not allocating anything on the heap. And this should be fine, I think. Yep. And setting this to identity, what I'll do is I'll create a vec4 as well, and I'll just set it to like so. And now what we'll do is we'll just do vec4 v1 is equal to I times v, and let's check out just to check if this implementation works, because I don't want to keep debugging it later on. Yep, we have errors. Hmm. 246. Let's check out. This should be vec4. And it is showing some errors here as well, where we are trying to in the identity thing. Yeah, I think we must, I'm not sure how to do operator overloading with two things. Can we do that? How do we do that? Is it given here? Nope. This is the way to do it exactly. It returns it, in our case it should return a float, and okay, it returns a reference to a 1D array. That's great. Let's try this out. I'll do this. This is the best for now. Yep. It worked. It worked. Right now I set it to an identity matrix, and I don't think I even need this method for identity matrix. I can keep it, but yeah. Let's try to initialize it with 2 along the diagonals. So like this should be 2 times. Yep, this works. So our 4 by 4 matrix implementation is working, and now the next step is to implement the projection and like perspective and orthographic projections, and then viewport transformations. Uh, so I think I'll end the stream now. I have to go somewhere, and after that I think maybe later I'll continue the stream and we can implement the projection stuff, perspective projection, that is for rendering 3D stuff and rasterizing 3D stuff, maybe a cube or something like that. And let me just add these changes before I leave. So guys, thank you for watching. If you are new to this channel, please consider liking and subscribing. I'll end the stream right now, and maybe I'll continue it later or maybe not. And have a happy new year.